In this next section, I'm going to talk about what's called inverse trig functions. So inverse trig functions are used in order to determine the angle when it's not given. So sine inverse is written as sine of theta equals x, then theta is equal to sine inverse of x. So what happens is this sine goes on to this side. It's not dividing by sine, but it's taking the sine inverse of both sides. So if you take sine of an angle, it's going to give you a number. If you take sine inverse of something, it's going to give you the angle back. Cosine inverse, we write as cosine inverse of x, and tangent inverse of x. So there is some confusion when it does come to sine and sine inverse. So I first want to make the point to write that sine inverse of x does not equal 1 over sine of x. Sometimes we will think of x to the negative 3 is 1 over x cubed, which is true, but that's not what this means. So sometimes sine inverse of x is actually written as arc sine of x to avoid this confusion. Keep in mind though that arc sine and sine inverse mean the same exact thing. These two are exactly the same. Alright, it's time to do example 5. In example 5, we're going to use a trig function to determine the measure of theta. And we're going to round to the nearest whole degree. So in this problem, we're given a triangle. We're given a side here and a side here. And just to be clear, this is our theta. So this would be the adjacent, and this would be the opposite. And this side here that we're not given is the hypotenuse. If we wanted to find it, we could use the Pythagorean theorem to find it, but we don't need to. So I'm going to write down what I know. I know my opposite is 26. I know my adjacent is 11. And my hypotenuse is unknown. Now again, we could go ahead and find it, but we don't really need to. So I'm going to write down SOHCAHTOA. And the reason I'm doing this is so I know which trig function to use. So I have the opposite and adjacent. So I'm going to use tangent. So the definition of tangent of theta is equal to opposite over adjacent. Now I just fill in what I know. So tangent of theta is equal to 26 over 11. Now this is where this starts to get different, because now we actually have to use the inverse function. So you write it like this, tangent inverse of both sides. So these will actually cancel each other off. Again, you're not dividing by it, you're taking the inverse of it. So theta is equal to tangent inverse of 26 over 11. And at this point, you just have to put that into a calculator. So I type in tangent inverse, and on your calculator it should be like shift tangent, or one of the buttons will be tangent inverse. 26 divided by 11, and you push enter, and I get 67.067. So theta is approximately 67.07. And then I'm going to round that to the nearest degree. So theta is approximately 67 degrees. Don't forget the degree symbol, it's very important. So on your own, I want you to try to determine theta for both of these triangles. Alright, let's give it a go. So in this problem, I'm going to label my triangle. I'm going to do this a little faster now. This is my opposite. This is my hypotenuse. And this is my adjacent. So now I'm going to see that I have the opposite and hypotenuse. So I'm going to want to use sine. So I get sine of theta is equal to 14 over 16. You could leave it like that, but I'm going to reduce it. Sine of theta is 7 over 8. And now what we do is we take sine inverse of both sides. So these cancel off, and I get theta is sine inverse 7 over 8. And I'll put that in my calculator in a minute. I'm going to go ahead and solve the second one first. So here I have my adjacent and my hypotenuse. So here I'm going to want to use cosine. Cosine is adjacent over hypotenuse. So I get cosine of theta is equal to 5 over 12. So again, I take the inverse of both sides. And these cancel, and I get theta is cosine inverse of 5 over 12. Now all that's left to do is put these into my calculator and round them to the nearest degree. So the first one's going to be sine inverse of 7 divided by 8, and I'm going to get 61.04. And the second one is going to be cosine inverse of 5 over 12, and I'm going to get 65.37. So for part A, it was about 61 degrees, and for part 2, it was about 65 degrees.